All right, guys, we're going to be moving on to 4.4a, and you're going to think by the time this thing's over, we're never going to get through 4.4. But I want to kind of explain that to you before we get started. 4.4 in our book, it basically just throws you right into factoring, and I didn't really want to do that. Again, with a lot of people being on NTI still, I didn't want to try to just throw you into it. So what we're going to do is we're going to kind of build up to how you even come up with a quadratic expression, and through multiplying and some different things, and then we're actually going to look at how to break those back down, which is basically what factoring is. So we're going to start here today again with 4.4a, which is adding and subtracting, multiplying quadratic expressions. And so a lot of this should be pretty simple for us, but I want to just again not assume anything and really just take a look at a few of these and make sure we know how to do them. So I want to start with so let me get me a different color here. Let's see. We'll try purple. We'll try it. All right. So I'm going to start with number 2 right here. And so what you're doing here, if you notice, I've got addition here. I'm adding. This is actually called a binomial. And here I've got a trinomial because I've got 3 parts. And so I'm adding all of these terms together. One of the first things I want to note out to you is that really, truly, you don't really need these parentheses. They put them in there. Now, they are important when we talk about subtraction, which we're going to do here in just a few minutes. But when you're adding, really, those parentheses doesn't add any value to this problem whatsoever, okay? So as a matter of fact, what I'm going to do first thing, I'm going to go ahead and just write it without the parentheses. Okay. So right there, that's all written out without the parentheses. Now, one of the things we need to think about when we are writing out polynomial expressions is that we need to start with the highest degree first. And the degree, of course, is your exponents. You notice these are just constants, like a -5, a +4. Those are just constant numbers. They don't have a variable term with them. Whereas here you have 2n, and really we could say that 2n is being raised to the first power, as well as this 4n over here is being raised to the first power. But you have -6n raised to the second power. So anytime you're listing these out, you need to make sure that you always go in descending order, which means you're going to start with the highest degree first. So again, if we were to look at the only term that has an n squared is this one. So this would be my biggest term that I have. So I'm going to go ahead and list it out first, -6n squared. Okay, so that one's kind of taken care of. I've kind of finished it. And now I'm looking for like terms that go down in descending value. So here this was n squared. I want to go down to the ones that have n to the first. Well, here I have a term. And remember that sign always goes with the term. And there I have a term. So I have +2n plus 4n, which equals +6n. Now, a lot of people, they try to go ahead and add these together. This 1 plus 1, but again, it's just like saying I have 2 red apples and I've got -6 blue apples. So those are totally different things, and we have to kind of recognize that those are like terms, okay? And so those now go away, and the only thing I have left is a -5 and a +4. So -5 plus 4 is going to be -1. So that would be, this would be my simplified expression, okay? And that's kind of what my instructions are, simplify each expression. Where it gets a little bit confusing is when we go to subtraction, okay? And it seems like subtraction, division, all those things kind of get us a little bit fuzzed up. But what I want you to realize here, again, let's look at number 1. If you look at number 1, I have a binomial here, but I'm subtracting this whole trinomial from that, okay? And actually, I tell you what I want to do. I want to maybe get some more real estate here with this particular problem to kind of show you another way to kind of look at this. Actually, I'm not going to have room to do that. So let's just work this out. So what I want you to think about is you've got a negative here. You also have a 1 right here, right? So really what's happening is you're distributing this -1 through this entire trinomial, okay? And so what you need to think about is that if I multiply by -1, I want you to just think about this for just a second. What happens to each of my terms? if I multiply by a -1, it's kind of like doing the inverse, okay? So instead of a positive 4p squared, this is going to be a negative 4p squared. Instead of a negative 8p, this is going to become positive because a negative times a negative becomes a positive. And the same with this positive 10. This positive 10 is going to become a negative 10. So what I want you to think about is when you're subtracting, actually you're going to flip the terms on everything that's here because it's really like multiplying by the opposite. And I know that's maybe a little bit confusing. But again, what I'm going to do is the same thing I did over here. I'm going to rewrite this problem just in the form of addition. So I'll show you what I mean. This -2 plus np, that's going to be exactly the same. But now I'm subtracting a 4p squared. So subtracting a 4p squared would look like that. Now I'm subtracting a negative 8p. Well, if I subtract a negative, then that's the same thing as adding 8p, okay? And last but certainly not least, if I'm subtracting a positive 10, I'm actually subtracting 10, okay? So now let's just take a look at our like terms and what we have. And remember, we're always going to start with the highest degree term. So our highest degree term in this case, let me go ahead and change to another color, would be this negative 4p squared. So negative 4p squared would be the first thing I would write down. Secondly, I have a positive 9p and a positive 8p. So 9p plus 8p would be 17p. We barely can't see that yellow, but it's okay. And let's see, we'll come up with this. We already did blue. Let's get us another one. Let's go red. So the only thing left is a -2 and a -10. -2 minus 10 is going to be -12. So you can see right here would be our answer that we would have for this particular question. Okay? I know that looks like a 5-year-old wrote it, but it's okay, as long as we get the idea. So now let's go down here and let's look at these next ones. I'm going to look at number 11. So for number 11, you notice what we're doing. And if I gave you the same problem any other time, you're going to know exactly what to do. You know that anytime I have a number written right beside of a binomial term like this, that is in parentheses, that I need to distribute this -8 through. Okay, so the only thing I have to do here is -8. Oops, I made a mistake and you didn't catch me. I didn't give you time to catch me, right? So -8 times positive 3n. -8 times 3 would be -24, and the n just kind of comes along for the ride. And -8 times positive 3 would be -24. So there would be our answer. Pretty doggone simple, right? So that same process you would do for 12 through 14. And then we get down here to number 15, okay? And this is really where we begin seeing quadratics come into picture. And you're going to notice that that's a lot of the rest of your practice. There's a reason for that, okay? That's because that's a lot of what we're going to be doing the rest of this chapter. This up here was just kind of review. So let's look at this. Now I don't just have one term or a monomial times a binomial, but I have two binomials that need to be multiplied together. And so in this case, I want you to think again, it's really just like the distributive property. So I'm going to have to multiply this -8p times -7p, and I also have to multiply it times this +6. Now, if you think about it, I've just multiplied this term here times the two terms over there. Well, what about this one? Okay, so this is where now I'm going to multiply this term times that one and times that one. So that way everything has been distributed. So I want you to think about what we really just did. We multiplied the first terms. Think about it. This is the first term here, and this is the first term here. So we multiplied the first terms. Then we multiplied the outer terms, the first one and the last one. So those are the outer terms. You probably know where I'm going by now. Then I multiplied the inner terms, okay, which is I, and then I multiplied the last terms. This is the last term here. This is the last term in this binomial. So again, you've probably seen this before, but it's our friend full. It has come back, okay? So that's basically what you need to do in this particular occasion. But I want you to understand it's really just the distributive property. That's really all you're doing. So let's go ahead and let's work through this process on number 15. And I think that's going to be able to help you to get the rest of these finished up. Okay. So let's start with what we had here at negative 8p times negative 7p. Well, let's figure out the signs first. Signs usually get us more than anything else. So negative 8 times negative 7 is going to be a positive 56. Okay, now let's think about what happens here. We've got p times p. So think about it. I've got p to the first times p to the first. Well, what do you do when you multiply exponents? When you multiply exponents, you actually add them. So it would be p to the first plus p to the second, which would give me p squared. So you can kind of see where that p squared comes from right there. So 56p squared. Now let's move to our outer, which is what we're to do next. So negative 8p times positive 6. A negative times a positive is going to be a negative. I've got 8 times 6, which is going to be 48. And the p just kind of comes along for the ride. Again, there was no p here, so that's not going to be p squared. Okay? Now let's look at the next part. I've got my inner terms. Negative 3 times negative 7p. A negative times a negative would be positive. 3 times 7 is 21. And again, the p just kind of comes along for the ride. And last but certainly not least, I have negative 3 times 6, which is my last terms, which makes up the L in full. So negative times a positive would be negative. 3 times 6 would be 18. And the only thing we have left to do here is we have to combine our like terms. So remember, if I'm looking for like terms here, I'm trying to find anything that has the same variable and it's raised to the same power. So the only terms I have there that are like terms are this negative 48p and this positive 21p. Okay, so I'm going to go ahead and rewrite my problem one more time. Let's do it in black this time. It's 56p squared. Okay, negative 48 plus 21. Negative 48 plus 21 is going to be a negative because the 48 is bigger. And because it's bigger, I'm going to subtract. So 48 plus 21, because the signs are different, I'm going to end up with a 27p. And then the only thing left is the negative 18. And so here would be my final answer for number 15. And you do exactly the same thing on the rest of these as well, okay? So every single time, in this case, now tomorrow we're going to look at some different types here, some special products, if you will, in multiplication. But all of these should come up to a trinomial by the time you're done. If you've got 4 terms, then you obviously did not simplify somewhere along the path, okay? So shouldn't be very hard. Most of this is going to be review for you that you've seen before, but I want you to see where these quadratics come from so that when we get ready to start factoring, you'll kind of understand what needs to be done, okay? So if you need extra help, just make sure that you contact either me or Miss Wheeler, and we would be more than happy to get on a Google Meet with you or whatever we need to do in order to get you on the straight and narrow. All right? Thanks.